Given acceleration, we want to know velocity, so we need to take an antiderivative of acceleration. So going term by term, the antiderivative of t is t squared over 2. That's because the derivative of this term would turn back into this term. And one way you can do that is the power rule in reverse. An antiderivative, the power goes up by 1, but you need to compensate by multiplying by the reciprocal of the power, so 1/2, or in other words, just dividing it by 2. Same thing here, power of 0, power goes up to the power of 1, and if you multiply by the reciprocal of 1 is just 1. And then we need to always say, and when we take an antiderivative, there's an arbitrary constant c here. So to figure out what that arbitrary constant c is, they've given us some information. This is our velocity in general, but we need to tailor our velocity equation specific to the information they gave us. This says plug in 0 in for t, you should get out 3 for the velocity. So 3 for the velocity, 0 for t. So if you solve that equation, c is going to be 3. Okay, so now we know the full equation here. 3 there. And that's the velocity. We're going to do the same thing for the distance formula, the displacement. That's what we should say. So the power is a 2. The power is going to go up to a 3. We multiply by the reciprocal. Don't lose this 2 down here. We're multiplying by 1/3, so now this is 1/6. And then same thing over here. This is 3/2 t squared plus 3t plus that arbitrary constant c. They give us this initial information. If you plug in 0 everywhere, you're going to find out 0 equals 0 minus 0 plus 0. So c is going to be 0. Or you could just drop it. So that's our displacement formula. So the total distance traveled could mean, we traveled forwards and then we went backwards a little bit. Right? The total distance traveled would be this plus this. But if we were to just take an integral would add the positive and the negative areas to make it cancel out and it would give us this as a result, this little distance. Right? The total distance traveled means how much did we go forwards and then how much did we go backwards. And you can see forwards and backwards by graphing this real quick. It's a quadratic, or you could just pull it up in a graphing calculator like I'm going to do. So there's our velocity. The velocity dips below the x-axis between these 2 points. So what we're going to want to do is we're going to want to integrate between 1.268 and 4.732. That's negative area. And so like I was saying, that would be going backwards. If we add it together, that makes it look like we traveled less. So we want to just negate this amount. Okay? And so everything else can be positive. From 0 to 1.268, right before we start going negative, I want to evaluate this integral. And we need to subtract this one for the reasons I just mentioned. And I'm going to just put dot, 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 save myself some writing. And then we're going until t equals 6, so 4.732 to 6 of v of t here. So the antiderivative is going to be the same for each. This is, except for a sign on this one. This is t to the 3rd over 6 minus, it'd be quicker if we already have the antiderivative up here, right? So you could just plug in 1.268 in here. So let's do that. D of 1.268. Then we want to subtract. Let me think about that. I want to subtract D of 4.732 minus D 1.268 and plus this last one's got to be D, I don't know, maybe the other way would be quicker. D of 6 minus D of 4.732. Either way, doing this, where this is V of t, you get 4 separate integrals, the antiderivative is going to be the same, or this way should be fine too. I think we can make it a little easier on ourselves because you're subtracting a negative, so it's like plus D of 1.268. So we got 2 of those. minus d of 4.732 minus d of 4.732. So it looks like we have two of those, 2d of 4.732, and then we got plus d of 6. So with that algebraic combination, this is a little quicker. So 1.268 the third power divided by 6. Here's what I got. Oh, and then we need to multiply by 2. So here's what I got for the first one. Oh, this next one's going to be subtraction. So 4.732. Need to cube that. Divide by 6. I'm just using the d of t formula up here. Did I use that correctly? I don't know if I used it correctly for the first one. Let me check. D to the third over 6. I don't think I did. 1.268 squared times 3 divided by 2. I want to subtract that from the previous result. Just lost it. Okay, so I plugged it in incorrectly here, so I'm going to pause the video. All I'm doing is I'm plugging 1.268 into d of t. I'm going to plug 4.732 into d of t. I'm going to plug 6 into d of t. Here's what I got, which when you add those together, that's 6.93 to the second decimal place.